Hello friends, now in this video I will explain all examples from practice set 2.2 and all solved examples before practice set 2.2. Now let us start. The numbers root 2 and root 3 shown on a number line are not rational numbers, means they are irrational numbers. Now see this here, the number line. Okay, from the origin O to A, the distance is 1 unit. Okay. On a number line, OA is equals to 1 unit. Point B, which is left to the point O, is at a distance of 1 unit. Coordinate of the point B is -1. Coordinate of point P is root 2 and its opposite is a minus root 2 as shown by point C. The coordinate of point C is a minus root 2. Similarly, opposite of root 3 is a minus root 3, which is coordinate of point D. Now let's learn irrational and real numbers. Root 2 is irrational number. This can be proved using indirect proof. Let us assume that root 2 is rational. So root 2 can be expressed in P upon Q form. P upon Q is a reduced form of rational number. Hence, P and Q have no common factor other than 1. Therefore, we can write here root 2 is equals to P upon Q. Now squaring on both sides. Then you will get square of root 2 is 2 and the square of P upon Q is a P square upon Q square. Okay. Now see this here. Again, root 2 is equals to P upon Q, squaring on both sides. 2 is equals to P square upon Q square. After simplification, you will get here 2Q square is equals to P square. Here, therefore, P square is a even number. Okay. Now next, P is also even, means 2 is a factor of P and this is the first one. As P square is equals to 2 times Q square and hence we will say that the P square is even and therefore its a square root is also even, means 2 is a factor of P. This is the first one. Next, P is equals to 2T. Next, P square is equals to 4T square where T belongs to set of integers. We'll substitute the value of this P square. It's a 4T square. Therefore, 2Q square is equals to 4T square and hence Q square is equals to 2T square. Q square is even and therefore Q is even. 2 is a factor of Q. This is the second one. From 1 and 2. Okay. 2 is a common factor of P and Q both. This is contradictory because in P upon Q, we have assumed that P and Q have no common factor except 1. Our assumption that root 2 is a rational number is wrong and hence root 2 is irrational number. Okay. Now next. Similarly, one can prove that root 3, root 5 are irrational numbers. Numbers root 2, root 3, root 5 can be shown on a number line. The numbers which are represented by points on a number line are real numbers. In a nutshell, every point on a number line is associated with a unique real number and every real number is associated with a unique point on number line. We know that every rational number is a real number. Okay. But here, but root 2, root 3, minus root 2, pi, 3 plus root 2, etc. are not rational numbers. Okay. It means that every real number may not be a rational number. Okay. Now the decimal form of irrational numbers. Find the square root of 2 and 3 using division method. Now see this here. This is the division method. Now to find out the square root of 2 by using the division methods, first we write 2 point. Then the pairs of zeros are here to the right hand side of 2. Here pair of 0, pair of 0, pair of 0. Okay. Now next we find the number which is the perfect square and it is equals to 2 or less than 2, and the perfect square number is 1 here. Therefore 1 into 1, the quotient is 1 here. Therefore 1 into 1 is 1, 2 minus 1. Then you will get here 1. Okay. Now next we add here quotient, that is a 1 plus 1. You will get here 2. Next we will take one pair of these 0. The number will become again here 100. Now next we take to the unit place of a number, and whatever that number we get, we multiplied with that same number. Then that number must be equal to this 100 or less than 100. And here if we take 5 on the to the unit place, then that number will become 25. 25 into 5, then you will get here 125. That number is greater than this 100, and hence here we will take here, that is a to the unit place 4. Therefore 24 into 4, then you will get here 24 into 4, that is a 96, and the quotient is here 4 here. Therefore 100 minus 96, you will get again here 4. Again we add here this quotient number, that is a 24 plus 4, you will get here 28. Again one pair of 0, and the number you are getting here 400. Now next again we will take here the for the unit place a number such that that number is multiplied with the upcoming number, that is here we are taking 1 to the unit place and 281 into 1. Again you will get here 281. After their subtraction you will get here 119, and again here we add the quotient, that is a 281 plus 1, then you will get here 2824. Now next again we will take one pair of 0, and then you will get here 11,900. And next we will take here to the unit place as a number 4, and we will multiply this number, that is a 2824 by 4, and then you will get here 11,296. Again their subtraction is a 604. Again we will take the pair of these 0. Okay, 4 is added to the 2824, then the number will become 28,282, and in this way this division is in a continuous process, and therefore the root of 2 is written as, that is 1.41421 dash dash. Similarly, the square root of 3 here. Now see this here 3, and the pairs of 3 point, pairs of zeros are here. Now the first, the perfect square, 3 is not perfect square. The number which is a perfect square and which is less than 3 is a 1 here. That is again 1 into 1, then you will get here 1. Okay, 3 minus 1, you will get here 2. Again, we will add here the quotient, that is the 1. 1 plus 1 is 2. Again, we will take here the one pair of 0. The number will become 200. Now, we will take a number to this unit place, which is the 7 here. That is 27 into 7. Then you will get here 189. Then next, 200 minus 189, you will get here 11. Okay, next 27, we add here the quotient, which is the 7. 27 plus 7, then you will get 34. Okay, again next we take the one pair of the 0, the number will become 1100. Okay, next again we will take the to the unit place the number 3, we will multiply 343 by 3, and then you will get here 1029. After subtraction you will get here 71. Next again we add the quotient number, these 3. 343 plus 3, then you will get here 346. Okay, the here the remainder is a 71. Again we will take the one pair of the 0. Okay, again next to the unit place we are taking here the number 2, that is a 3462. into 2, then you will get here 6924, and thereafter subtraction you will get 176. Again we add here the quotient, that is a 2, then you will get here 3464. This division is in a continuous, it is a non-terminating and the non-recurring. Therefore, root 3 is equals to 1.732 dash dash. Okay. And this type of the division is a non-terminating and the non-recurring. Note that in the above division, the numbers after decimal points are unending, means it is not terminating, non-terminating. Even no group of numbers or a single number is repeating in its quotient. So decimal expansion of such numbers is non-terminating, non-recurring. Okay. Root 2, root 3 are irrational numbers. Hence 1.4142 dash dash and 1.732 dash dash are irrational numbers too. Moreover, a number whose decimal expansion is a non-terminating, non-recurring is irrational. Okay. Now next, ratio of the circumference of a circle to its diameter is a constant number which is irrational. Now see this here. If you measure the circumference of the circle divided by the diameter, that is a 2 into radius, then you will get the number pi. Okay. This constant number is represented by symbol pi. So the approximate value of pi is a 22 upon 7 or 3.14. Okay. The great Indian mathematician Aryabhatta in 499 Christian era has calculated the value of pi as, that is a 62,832 upon 20,000, that's equals to 3.1416. Okay. Now next we know that root 3 is an irrational number because its a decimal expansion is non-terminating, non-recurring. Now let us see whether 2 plus root 3 is irrational or not. Okay. Now see this here. Let us assume that 2 plus root 3 is not irrational number. If 2 plus root 3 is a rational number, then as it is not irrational, then it is rational number. Then we will express this rational number, that is a 2 plus root 3 is in the form of the p upon q, where 2 plus root 3 is equals to p upon q. As it is not rational, then it must be, as it is not irrational, then it must be rational. That is a 2 plus root 3 can be written as in the p upon q form. Next, we get here root 3 is equals to, we will take this 2 to the right hand side, then it will become minus, therefore root 3 is equals to p upon q minus 2. Now here in this equation, left side is an irrational number, this is the left hand side, it is irrational number, and the right side rational number, this is the rational number which is contradictory. So 2 plus root 3 is not a rational number, but it is an irrational number. Means what? Whatever our assumption, that is wrong, and hence 2 plus root 3 is a irrational number. Similarly, it can be proved that 2 root 3 is a rational number. The sum of two irrational numbers can be rational or irrational. Let us verify it for different numbers. Okay. Now see this here, 2 plus root 3 plus minus root 3. Here plus root 3 minus root 3 get cancelled and you are getting the 2. Means what? The addition of these two irrational numbers, we are getting here rational. Now the division of irrational numbers, that is a 4 root 5 divided by root 5, that is a division of irrational numbers, and you are getting here 4, and 4 is a rational number, therefore the division of irrational number is rational. Next, 3 plus root 5 minus root 5, here again root 5 plus root 5 minus root 5 get cancelled, you are getting the rational numbers. Now next, multiplication of irrational numbers. Here 2 root 3 into root 3. Then you are getting root 3 into root 3, that is a 3. 3 into 2, 6. Next, root 2 into root 5, you are getting the root 10. Again, it is a irrational numbers. And this multiplication of irrational number is rational. This multiplication of irrational number is irrational. Next, subtraction of irrational numbers means what? 2 root 5 minus root 5. You are getting the root 5. It is a irrational numbers. And hence, here we say that the sum of two irrational numbers can be rational or irrational, and we have verified it. Now next, remember these properties of irrational numbers. First, addition or subtraction of a rational number with irrational number is an irrational number. Multiplication or division of non-zero rational number with irrational number is also an irrational number. Next, addition, subtraction, multiplication, and division of two irrational numbers can be either a rational or irrational number. Now, next, properties of order relation on real numbers. If A and B are two real numbers, then only one of the relation holds good here. What is that? That is A is equals to B, or A is less than B, or A is greater than B. If A is less than B and B is less than C, then A is less than C. Next, if A is less than B, then A plus C is less than B plus C. Next, if A is less than B and C is a positive, then A into C is less than B into C. And if C is negative, then AC is greater than BC. Verify the above properties using rational and irrational numbers. You can verify all these properties. Now, square root of a negative number. Now, see this here. We know that if root of A is equals to B, then the square of squaring on both sides, then you will get here. If you square this B, then it will become B square, and the square of root A, that is equals to A. Here B square is equals to A. Hence, if root 5 is equals to x, then squaring on both sides, then you will get here x square is equals to 5. Similarly, we know that square of any real number is always non-negative. This is important. Square of any real number is always non-negative. Now next, see this here. It means that square of any real number is never negative. But in this case, see this here, but in root of minus 5, bracket square is equals to minus 5. Therefore, root of minus 5 is not a real number, and hence square root of a negative real number is not a real number, and we say that it is a complex number. Okay, this is important. That is, square root of negative real number is not a real number. Now we'll start the practice set 2.2. Now first, show that 4 root 2 is an irrational number. Now proof. Let us suppose that 4 root 2 is rational numbers. We want to prove that it is irrational number. But here we will apply the indirect proof, and hence we assume that it is a rational number. 4 root 2 is equals to A upon B. As it is a rational number, we can express this the rational number in the form A upon B, where B is not equals to 0. A and B are integers. Okay. Now after simplification, then you will get here root 2 is equals to A upon 4B. This is the first expression. Now here A upon 4B is a rational number because integers are rational numbers. Okay. All these are the integers are rational number. This whole number is a rational number. The right hand side of the equation 1, this is the right hand side of the equation 1 is a rational number. This is the rational number. And what about the left hand side? The left hand side root 2 is irrational number. This is not possible. Rational number is not equals to irrational number. This is rational, this is irrational, and they are not equal. This is the contradictory. Therefore, what is our assumption? Our assumption that is a 4 root 2 is a rational number is wrong. Therefore, our assumption that 4 root 2 is a rational number is wrong, and hence 4 root 2 is an irrational number. Now next, prove that 3 plus root 5 is an irrational number. Again here we will apply the indirect proof. Okay. Let us suppose that 3 plus root 5 is a rational number. We want to prove that it is a rational number, but here we are using again indirect proof. We are supposing that it is a rational number. As it is a rational number, we can express in the form a upon b, where b is not equals to 0, a and b are integers. Next, root 5 is equals to a upon b minus 3. This is the first expression. Here the right hand side of the equation 1, that is a subtraction of the two rational number, is a rational number. This is the whole rational, overall this is the rational number, but to the left hand side it is a irrational number, and this is not possible. That is here the right hand side of the equation 1 is a rational number, and the left hand side, that is a root 5, is an irrational number. This is contradictory. Therefore our assumption that is a 3 plus root 5 is a rational number is wrong, and hence therefore 3 plus root 5 is an irrational number. Now next, represent the numbers root 5, root 10 on a number line. Draw a number line L. Take OP is equals to 2 unit. Draw PQ perpendicular to line L. Here we have drawn the PQ perpendicular to line L. We have taken the OP is equals to this 2 unit. Okay. Take PQ is equals to 1 unit. Okay. PQ is equals to 1 unit. In right angle triangle OPQ, this is OPQ is a right angle triangle by Pythagoras theorem. OQ square, that is a square of the hypotenuse, is equals to OP square plus PQ square. Therefore 2 square plus 1 square, you will get 4 plus 1. Therefore OQ square is equals to 5. OQ is equals to 5. Here OQ square is equals to 5. Okay, by mistake it is only written as OQ. OQ square is equals to 5. Therefore OQ is equals to root 5. With the center O, OQ as a radius, we will take OQ as a radius. Draw an arc intersecting line L. Here we will take the O as a center, OQ as a radius. Draw the arc intersecting the line L at the point R and treated it as root 5. Draw an arc intersecting line L in the point R, or that is here OR is equals to root 5 on the number line, and hence we have represented root 5 on a number line. Okay. Now next, that is the coordinate of the point R is a root 5, and similarly we can find point U on the number line L such that OU is equals to root 10. Similarly here, draw the perpendicular here ST and take this distance OT as a radius. Draw this arc. It will intersect to the line L at the point U, and this distance is nothing but a root of 10. Okay, how it is a root of 10? That is this OS, that distance is 3. 3 square is a 9. Again, this ST square, that is a 1. 1 square is 1. 9 plus 1, that is a 10. And the root of the 10, that is nothing but the OT, and take O as a center and OT as a radius. Draw this arc. It will intersect to the line L at the point U, and hence the distance OU is equals to root 10, and we have represented root 10 also on the number line. Now next, write any three rational numbers between the two numbers given below. This is open-ended question. The first is 0.3 and minus 0.5. Now we'll find out the irrational numbers between 0.3 and minus 0.5. Now first, here we will add these two numbers and divide it by 2. That will be the number between these two numbers. That is 0.3 plus in bracket minus 0.5. Okay, that is 0.3 minus 0.5 divided by 2. Okay, their sum is minus 0.2 upon 2. You will get here minus 0.1. Okay, now next, the number between minus 0.1 and this 0.3. First we will find out the average of these two numbers. Okay, and that is minus 0.1. Next we will find out the number between minus 0.5 and minus 0.1 and 0.3. Okay, minus 0.1 and 0.3. Okay, divided by 2, the number between them, that is 1 upon 2 minus 0.1 plus 0.3. Their sum is minus 0.1 and plus 0.3 means what? 0.2. Okay, then you will get here 0.1. Okay, next the number between minus 0.1 and minus 0.5. Okay, therefore 1 upon 5, 1 upon 2 in bracket minus 0.1 plus in bracket minus 0.5 in bracket you will get here minus 0.6 divided by 2, and then you will get here minus 0.3, and hence the numbers that is between 0.3 and minus 0.5 are minus 0.3, minus 0.1 and 0.1 are the three rational numbers between the numbers 0.3 and minus 0.5. We can find out using this method also. Next, that is the numbers between minus 2.3 means what? Minus 2.300 and minus 2.33, that is a minus 2.330. Now see this here again, the same method. Okay, that is the average of these two numbers means what? 1 upon 2 minus 2.300 plus in bracket minus 2.330. Okay, that is 1 upon 2 in bracket minus 2.300 minus 2.330, and their sum is a minus 4.630 divided by 2. Then you will get here minus 2.315. Next, the numbers between minus 2.315 and minus 2.300, again their addition is a minus 4.615 divided by 2. Then you will get here minus 2.3075. Next, number between minus 2.315 and minus 2.330, we add them and divided by 2. Then in bracket you will get here 1 upon 2 minus 2.315 minus 2.330. Okay, and their sum is a minus 4.645 divided by 2, that is equals to minus 2.3225. Okay, and these are the numbers between 2.3 and minus 2.33. Okay, what are the numbers? That is a minus 2.3075 minus 2.315 minus 2.3225 are three rational numbers between minus 2.3 and minus 2.33. This is open-ended question. In another way, you can also solve this. Okay, now we have taken this another method here. That is the numbers between 5.2 and 5.3. You can also apply this method. I have shown both the methods. You can add these two numbers divided by 2. You will get the mean number between them, and the mean and this number divided by 2, mean and this number divided by 2. That method I had already explained. Now then, this is the next method. Now 5.2 and 5.3 can be written as 5.20 and 5.30. Now the numbers between 5.20 and 5.30 are 5.21, 5.22, 5.23, 5.24, and in this way up to 5.29. These are the numbers. You can apply this method also. Now next, the numbers between minus 4.5 and minus 4.6. Again, minus 4.5 can be written as minus 4.50 and minus 4.60 can be written as minus 4.60. Okay, now the numbers between these two numbers are minus 4.51, minus 4.53, minus 4.54, and in this way. You can select any three numbers between them. And in this way, I had completed the practice set 2.2. Now we will see in the next video. Till then, goodbye.